Hi folks, welcome to another Aviate webinar. I'm here with Wade Evans, and here we're going to help you specify your AV-HMALS system, including a series of steps. Wade is the project and solutions manager based in Melbourne, Australia for aviation and digital verticals within the Sealight and Avlight group. Myself, I'm the regional sales manager for the Americas, both Avlight and Sealight. Today, we're going to talk to you about specifying your AV-HMALS system, different applications it can do, and what components make up an HMALS system. Finally, we'll go through a step-by-step process in how to specify and design your AV-HMALS system. And Wade, before we do this webinar, it occurred to me, we've, as a team, done 4 separate design systems delivered in the last 12 calendar months. We did the US Army MOT system in September, did the IELTS system in December, the solar solution for AFRICOM in January, February, and then the wired solution that went to the Royal Saudi Air Force. That's a lot of configurations in 1 year. Wade, what was your favorite HMALS system that was designed and delivered this year?
My favorite would have been the IELTS system. I think it's a real leading edge, cutting edge system, and obviously part of a really significant deployment and DoD application space. So I think the IELTS system was definitely a leader.
So understanding your runway. So the biggest driver for your AV-HMALS system is going to be your requirements. Is it going to be a 5,000-foot runway, 10,000-foot runway? Are you going to need PAPIs, full approach, taxiway on both ends? The biggest drivers are, the anticipated runway layout. Mostly length, but width can become a variable that needs to be reviewed. You can see here Mauser system with 9 barrettes. Not shown are the 5 sequential flashers, threshold lighting, runway edge identifier lights, PAPI for one side, but you could split that single PAPI into 2 2-box PAPIs for 2 different approaches. And the flexibility is really what's key here for the HMALS system and what we're going to go over today. Variable to your specification for your HMALS system is transport and storage, where you're going to keep it and how you're going to get it to the theater of operations, what type of deployment you're going to be doing and how quick you need to get the system up, and is it going to be a quick deployment or sustained deployment? And there's some different options based on how long the system will be deployed. Shown here is a C-17 Globemaster, U.S. Air Force jet aircraft at Alpena Combat Readiness Training Center, where the IELTS evaluation took place. So your first evolution with an HMALS system is going to be the storage and transportation. Avlight offers roadworthy and high-density configurations, and integrated charging is recommended for most all applications. Shown here is a portable PAPI system being installed in Alpena as well. A real key component of the AV-HMALS system is its portability and ruggedness. We're expecting these systems to be deployed and reconstituted, reconstituted multiple times, and they really need to be built with precision, and a lot of thought goes into making them available for multiple deployments. A portable system, in many cases we've experienced around the world, can be transitioned to a sustained operation, whether it's through commercial AC, solar, or generators. But the main point of the AV-HMALS system is it can be immediately deployed and operated to bring aircraft down safely. So there's a variety of different use cases for the AV-HMALS system, whether it's domestic, deployed, forward operating in a hostile environment, or for humanitarian missions. And some of the key features of the AV-HMALS system is its low power consumption, low fuel consumption, because in those environments, fuel is a key resource. And finally, it can be used right away or for sustained operations, whether it's 3 months, 6 months, or 5 years or longer. We have use cases around the world going on 10 years. So as we move on, I'm going to have Wade talk a little bit more specifically about the product.
Thanks, Jason. So Jason's run through the applications and the high-level summary of the AV-HMALS product. I'm going to delve a little bit more deeper into detail, walk through the individual constituent elements of what makes up a AV-HMALS, and then give a bit more detail about that so that you can apply it in your own individual use case and find out the appropriate use case for these products themselves. So we'll start off with trailer systems. As Jason mentioned, we really have two types of trailer systems, either the roadworthy trailer or the high-density trailer. With the roadworthy trailer, which is the top picture there, it's suitable for both improved and non-improved terrain, which means on-road and off-road. This is the system that's ideal for great flexibility for different applications and provides the greatest flexibility for your deployment, given it can be used on multiple terrain types. It has a standardized towing interface and it's NATO air transport compatible. As with all of our trailer systems, its AC charging system is integrated into the unit and allows for charging of the individual fixtures from an AC source when it's not in use. From the roadworthy trailer, we move on to the high-density trailer. So the high-density trailer on the bottom there is the high-density footprint, which is ideal for tarmac applications, which Jason mentioned. It optimizes our total transport profile because it maximizes the number of fixtures per trailer, which allows for the most dense and fully fielded trailer space. It's standardized to an intermodal container system, which means it meets the requirements of standard transport metrics and allows for those standard transport metrics to be utilized to deploy the system. And then also has an AC charging system integrated, just like the roadworthy trailer. From trailers, we'll move on to runway lights and taxiway lights. So with runway and taxiway lights, they're really the core of a HMALS deployment in terms of the lighting fixtures themselves, because they fulfill a really key requirement for the taxiway and runway lighting applications. So when it comes to runway lighting, we're talking about omnidirectional, bidirectional, or unidirectional light fixtures, and they identify either the edge, the end, or the threshold of the runway. It's really two key products we utilize in HMALS applications, and they're the AV-426 and the AV-WRL. So the AV-426 is on the top right there, which is our self-contained solar fixture. It contains obviously the solar system itself to maintain charge into the battery. It is also compatible with wide systems, such as an AC long line implementation. That fixture comes in all the standard configurations, being edge and then threshold configurations, and is RF and PLC communication compatible. When I say PLC, I mean power line communication, which uses the AC long lines to communicate with the fixture. Now from the AV-426, we'll move on to the AV-WRL, which is in the top left-hand corner there, or the AV-WRL as we call it, which is our wide fixture. So it comes with a battery backup that is predominantly designed to be connected to an AC long line, which charges the battery, but also sustains the light fixture itself. The AV-WRL meets all the same requirements as the AV-426 in terms of its application space with edge and threshold identification, and threshold lighting, should I say. The only difference being that it doesn't contain the solar for charging as a self-contained solar system designed for sustained solar operation, which isn't always required in HMALS applications. From runway lighting, we then move on to taxiway lighting. So the bottom images are our taxiway fixtures, and taxiway lighting is really designed to map the edge of the taxiway at nighttime or low visibility requirements. It's really to guide pilots after landing. The three components of our taxiway lighting range for HMALS applications is the solid taxiway light, the AV-70, the AV-WRL, which we mentioned before, and also the taxiway reflector. The solar taxiway light, the AV-70, which is in the bottom left-hand corner, is our solar self-contained taxiway light, and has the same interfaces and compatibilities as the AV-426 in the top right-hand corner. This means that it meets the taxiway applications, but is compatible with AC long lines and AC charging, as well as RF and PLC communication. The AV-HMALS, which I mentioned before, does come in a taxiway configuration, meaning it can meet the taxiway requirements in the same form factor and same interfaces as I mentioned previously. And then rounding out the taxiway lighting requirements, we have taxiway reflectors, which provide that reflective surface for taxiway identification.
And I think we should note, Wade, any of those fixtures can be deployed with or without cabling.
Yeah,
for temporary and in some cases permanent use.
Yeah, exactly. Yeah, so just leveraging what Jason said, all of these units can be deployed without having to be permanently wired to start with, which means they can be deployed in a battery-only situation during that rapid deployment phase that Jason mentioned. So that allows it to be deployed, activated in an operational circumstance and an operational application straight away without having to run any infrastructure to get the system up and running, which is really critical when you talk about expeditionary airfield lighting or any of these portable airfield lighting systems. So moving on to the approach lighting. For HMALS, we really build the approach lighting around a couple of key configurations, which are made up of a bunch of different elements. So the key configurations that are supported through HMALS are the MAS configuration, which is the medium intensity airfield lighting system with runway end identifier lights. The SEALS system, which is the short simplified expeditionary airfield lighting system, and then the SALS, which is our short approach lighting system. So these are predefined configurations of approach lighting that use a range of different product to build those predefined configurations. This gives a lot of flexibility in terms of how the AV-HMALS product is utilized and deployed. And a lot of the fixtures within these standard configurations can be redeployed and realigned in order to meet other requirements and other configurations as well. Now, the elements that make up these standard configurations are displayed there on the right. But the first of those is steady burning barrettes, which is in the bottom left-hand corner. There are unidirectional approach lights in a barrette configuration, mechanical barrette configuration, designed to meet the requirements of unidirectional approach lighting. They're also portable. They fold up on the barrettes for portability and transport reasons, but ultimately fulfill that application within the approach lighting segment. They're then also supported by the standalone steady burning lights, or the SSBLs, which is in the top left-hand corner. There are self-contained solar steady burning lights designed for portability and self-contained solar charge, as well as compatibility with AC long lines and RF control as well, if and when required. The standalone sequence flashing lights, which are on the top right-hand corner, are similar to the standalone steady burning lights. In fact, they're a self-contained portable unit, which can be supplemented by a standalone solar system as well, designed to meet the same sort of requirements and needs as that standalone steady burning light. And the approach lighting portfolio is really rounded out with the PAPI, or the AV PAPI, which is our precision approach path indicator in the bottom right-hand corner. It's available in 2 and 4 box configurations, depending on the needs and the application you're using it in. But it completes the approach lighting portfolio and allows you to meet some really specific requirements, but also provides quite a bit of flexibility in terms of how the AV-HMALS product is deployed in the various deployment situations.
Wade, would you mind explaining the difference between the steady burning light and the sequence flashing light, the mechanical interfaces and where the solar goes?
Yeah, certainly can. So with the standalone steady burning light, the solar is contained, self-contained solar, as you can see in the image in the top left there. So the solar panels are actually physically on the unit. All the charge regulation is also internal to the unit to power the fixture to provide that solar charge and sustain it in applications where you may have an AC failure. Now the sequence flasher on the right still contains a battery in the mechanical assembly, that battery backup, but is supported by an additional auxiliary solar panel in order to provide the solar charge for that standalone application. The reason for that is there are obviously different form factors, different profiles, mechanical profiles, which means that it's not possible to integrate the solar on those fixtures. And the power requirements also dictate a need to segment the solar off. Okay. So moving on to controls and accessories. Obviously, I've spoken about the individual products that make up the HMALS system, but they're all rounded out with a bunch of accessories as well as communication systems that allow it to all work in concert. So Control is absolutely critical for the AV-HMALS product range. It allows for that single point of control and command that allows the airfield to be utilised in multiple different applications and use cases, and can meet the needs of that specific deployment as and when required. So there are really two key communication interfaces we utilise with HMALS. They're RF and PLC. So RF being radio frequency, which is illustrated by our RF handheld controller on the left there, and then PLC being power line communication. So the difference between the two is obviously that RF utilises radio frequencies to do the control, as where power line communication utilises the AC power sources or the AC long lines with a modulated signal in order to control the fixtures themselves. Now, they're not mutually exclusive. You can have systems that utilise both RF and PLC, and it actually allows you to provide additional communication redundancy within the system if and when required. Now, a user may only require one of those communication interfaces, depending on how they want to deploy the system. But at the same time, you can use both of them if required. So for accessories, they really round out the offering for AV-HMALS. The goal of AV-HMALS was really to provide a turnkey solution for expeditionary airfield lighting. So you need to be able to contain and store the accessories as well. So a couple of the key accessories we provide as part of AV-HMALS are the distance remaining markers and the hold signs, sign lights, wind cones, and cable protectors. They're all included within the package and within the individual trailer systems and storage systems. And they really help to facilitate the requirements of a rapid deployed airfield, but also being able to phase it into the sustained deployment component of an AV-HMALS system. So that's a bit about the product. Next, we'll walk through a step-by-step process of how you define your HMALS system. And this is the same process that our sales team and our AvLight team would utilise in order to help you move through the AV-HMALS product line and decide what is the best configuration for your given application. So step one is always to decide the application and the runway layout for your implementation. So application is absolutely critical. What terrain is it going to be utilised? What is the length of the runway? What's it being used for, and what aircraft are going to utilise that deployment. After you define the application and the runway layout, you then define next configuration of the trailer, the power systems, and the control requirements. So as I mentioned before, when it comes to the trailer, you can select from roadworthy or high density. They're obviously directly interlinked to the previous step when you've defined your application and the runway layout. So if it's a application that requires off-road terrain, for example, you'd be looking for a specific trailer system that met those requirements. On top of the trailer configuration, you then need to select your power requirements. So depending on how you're utilizing the system, what use case you're using it, is it on demand only? Is it going to be utilized consistently with an AC feed? Because we have gensets, we have those capabilities within the HMALS system as well. So you need to define what power system you're going to be utilizing. Is it going to be solar? Is it going to be AC with battery backup? Or is it going to be AC with battery backup and solar for added redundancy? On top of that, you also define what communication method you want to utilize. You can utilize PLC or RF, or a combination of both. After you decide on those three key components, you then move on to define your approach system for the HMALS product. As I mentioned previously, we've really got three core configurations within the AV-HMALS line, which is the Mauser, the seals, or the SALs. So once you've defined which of those configurations you need to utilize, or which combination of those configurations you need to utilize to meet your application space, you'll then know exactly which products need to be able to comprise of that. On top of the individual approach lighting systems, you can always select your PAPI as well, and that's available in 2 or 4 box configurations, which round out the approach lighting requirements. After you selected approach, you then move on to actually select the individual fixtures that you want to utilize in the application. That could be a range of edge lights, obstruction lights, threshold lights, and depending on what you've defined in the previous steps, power, the trailer, the control requirements, you'll be pushed towards different types of fixtures that suit that application. It might be an AV-well, might be an AV-426, maybe an AV-70, and then the accessories that go along to support that. And then on top of that, depending on what approach system you've selected, will also dictate the kind of products that you'd be selecting from in terms of the individual approach lights as well. So that's a bit of a high level overview of the steps you work through to get to the solution or the HMALS product. I'll hand back to Jason just to round out the webinar and close it out.
Thanks, Wade. That was really good and gave us a lot of different inputs and variables that can help us specify that ideal HMAL system for your client or yourself. The key component of AV-HMALS is really its flexibility, whether it's power, trailer systems, number of lights, different approach lighting systems, all from the same original equipment manufacturer. We really have you covered, and we're really fortunate to be working with a diverse engineering and design team that's been doing expeditionary airfield lighting systems for more than 25 years. Systems that have been deployed around the world and still functioning today. So you've attended the introductory AV-HMALS webinar, which is module 1. Coming up in early August, we're going to do a virtual workshop where we'll work with you directly on configuring some HMALS systems and going over a lot of the different systems we can offer. Like I said, we're fortunate in the past calendar year to have delivered 4 discrete AV-HMALS systems, from all solar to wired with solar backup, all AC, and a mixture of the two. We've really benefited from a lot of diversity of inputs and using our global supply chain and engineering resources to create a really broad product portfolio. And we invite you to take a 60-second survey. And thanks for joining Wade and I.
Thanks, everybody.